Hi team, this is another video on Snowflake, and the focus today is on data engineering pipelines with the Snowpark Python. So data engineers focus on building and maintaining data pipelines to transport data from sources to destination. It is an ongoing practice that involves collecting, preparing, transforming, and delivering data to the target destination. So why Snowpark? Snowpark is a streamlined architecture. It is built scalable and optimized for pipelines. It acts with confidence with a lot of security feature integrated in Snowflake. It takes the advantage of virtual warehouse for scaling, tuning, sizing. We have Snowflake and Anaconda, which is the official single point of truth repository to get libraries and package for Python. Snowpark for Python features, we have client API with user-defined function stored procedure, vectorized UDF and table function. Here we have the SQL that use the query translator for be executed using the SQL engine, and we have a Python function that use user-defined function or procedure that will be executed on Python Secure Sandbox. Here, the good news also, because Snowflake is any source, now it is any code. Snowpark support Python, Java, Scala, and now with the Snowpark container service, it is general available because the screenshot it is a little bit old. So you can use a C++ or any code and encapsulate it into a service container and register it to the repository and use it as you do on on-prem or on other cloud provider. The benefits of Snowflake for data engineering, these features will be highlighted during the demo. We have Snowflake tables, not file-based, data ingestion using copy, command, schema detection. There is no schema defined in advance. We need the infer schema option. We have also the data sharing using marketplace, so there is no need to move the data. It is shared in real time. We have also streams for incremental processing on view and tables. We have user-defined function and stored procedure using the data frame API. And we have also the elasticity for the warehouse for the sizing and scale up, scale down. We are using Visual Studio Code with the Git extension and the Snowflake extension together with Snow CLI. And also we have an integration with the Git action for CI/CD. The dataset is belonging to this company, Tasty Bytes. So the workflow is as the following. We have a bronze layer to raw ingestion. We have a silver layer to data cleansing and data quality and integration of all business rules to transform the data. And we have the gold layer for the business level aggregate to have data ready to use for streaming, analytics, or AI reporting. We have also many type of environment to deploy the code from dev to QA and to production. Here, the project overview, we have these steps. These are the database object that will be implemented in the setup for the structure and the content using this demo. Here the workflow overview, we have environment setup, Snowflake setup, load raw data, get data from marketplace, create user-defined function, then create a view and stream. We create two other stored procedure to merge data in order table and in daily city metrics, and then orchestrate all the jobs using tasks. Finally, we will simulate manually a process of incremental load, and we will do the Git integration. And final tips is to load some Excel data to see how to do that. So for the environment setup, here we have Visual Studio Snowflake extension and Git extension, NoSQL, Snow CLI. We create Anaconda virtual environment importing the Python Spark Snowpark Python library, accept the Anaconda and Marketplace terms to have the ability to use the packages, configure credential in SnowSQL config file, and also we need a GitHub account for the integration with Git, and we need to use the GitHub repository for the quick start to do a fork and clone using the following link. Here we create the Conda environment, we activate the Conda environment, and we start by implementing the Snowflake setup. So let's go Snow. So here for the setup, we have steps here. It is the first step. Here we have the setup of account level object. We create the user, the role, and grant the required privilege. And we have also the database level object. We create the required structure for tables. For schema, we have external, pause, row, and harmonize analytics. And here we have also for the external, we have the stage, and we have the file format for Parquet file. So let's execute that. We have here the extension of Snowflake, and we have also the extension for Git. Let's execute. So here we have 25 statement here, executed with the X small warehouse. Here for the here we have these steps. We have the first step. We have a source Parquet file will be loaded to the raw pause and the raw customer, and then we will have the harmonized schema. We will have a view, flattened view with the stream, and the content of the stream for the change data capture will be loaded in order table, and we'll create another stream also on the table, and we have here a stored procedure to merge incrementally the content in the order table. And finally, we have the daily metrics here table that will use the Snowflake marketplace data that we will get with the order stream, and we will create order tasks to orchestrate all the jobs. Finally, we will integrate all the content to GitHub. We have here the Snowflake setup. So all the structure are here, and we will see here for Snowflake the query history here directly from Visual Studio without doing the back and forth to SnowSite. Let's see SnowSite here. There is no hand-on database, and that after this execution we have required objects are ready to have schema analytics. We have a function create here, the external schema, we have the stage and file format for Parquet. The other schema will be played. So here, if we see the content of the stage, for pause, we have to change. So here for the pause, we have these Parquet files. We have pause and the name of the table that we use it. For the customer also, we have same structure for the folder, only one file for customer loyalty, and for the Excel file we will see that later. We have two Excel files for location order detail. So the next step, you can see here it is the the demo is based on this quick start. We have all the details here, so I just do my own documentation, get some technical details, but all is here. So you can use it from Snowflake. You have the link for the repository also. So the second step here is load raw data. Here we need to the terminal and to load this data. So the content, the load started. So the load here, it is Python script. Here we create array for post table and customer, and we create a dictionary. Here the load table take the session and name and the stage and the year, the schema. Here, if the year is known, he will construct the path, and if the year is mentioned, he will construct the path with the year to get the right table. By the way, here for the load, we have only, for the first load, we will use only these years, 2019, 2020, and 2021, and the 2022 will be in step 9 for the incremental load simulation. So here we have a dynamic scaling here for the warehouse. We change to X large to accelerate the load. And here the loop for the collection, we take the table and the parameter and we start load the tables. Here we refer the load table function that construct and read the content of the table of the file. Here we use Snappy as compressor, and we use the unfair schema for the packet file, and then we copy into the target table. So we'll iterate. Finally, we resize the warehouse to X small as it was. Here we can validate also some content. And as you see here, the load is in progress. I will pause the video just to here the content of the file. Here we have this, and we have these tables that will be populated: country, franchise, station, menu, track, and all the detail and all the period. And here we have a customer loyalty. The execution is done locally, so I'm using my own laptop, and the load is in progress. So here the load is completed. We can also check from here from extension. See that create from Snow site. Also, we can exit this query and see that all tables are populated. So after the data check, we have the third step, which is Snowflake data marketplace. We need to just get the data weather source from the marketplace. So let's do that. Market from source. Here we have the free listing. So can just click here just to name it as mentioned in get option just to name in start and give the right to close it, and it is instantly done. Can check. Here we have new confirm that table. So here the data is ready to use from Snowflake Marketplace. Now we need to create a view in the harmonized schema. It is post flattened V, and it will join all these tables, and we will create also a stream on. Here we are in fourth step. We just to Python fourth, and we will see that the view created and the stream also created. And here for the content of script, here have first import and define the function here that create. It will be reference all the source table that we loaded with the data frames, and it will select only the required columns here. And finally, it will join us all. It will join all the data frame to get the final data frame here. And once the final data frame is ready, we create or replace a view according to Snowpark syntax. And then we create also in the harmonized schema here with the session SQL the theme on the. So here the view is created. As you can see here, the view is created and stream is created also. So the next step is to create and deploy UDF function. It is the Fahrenheit to Celsius conversion. So let's do it. So here we go to the path of step 5, and we will use local execution. So it is executed on my laptop. So here the result, we have the argument 50 and the result is 10. So now we need to deploy the procedure to Snowflake. So to deploy, we use snow command here, the snow CLI function create, and we'll deploy the content inside Snowflake. It will create the app zip and stage the content and create the function inside Snowflake. It is done. Can check. Here the function Fahrenheit is created. Signature using the app zip. So here we did the local execution. We deployed the function, and now we need to do a call to the function from SnowSite, from Python Visual Studio. So here we have a call from SnowSite for first call of argument 35. So here return values, and here we have the call from Snowpark Python origin. So here we use also Snow CLI to execute the function with the parameter. We'll see that the execution will be successfully, and we have the same result as we saw in SnowSite. So that's successful. Perfect. Now the step 6, we have a stored procedure. We will do a local execution, and we need to deploy, and then we need to do a remote execution from Snowflake. So we just need to explore the code a bit. So here we have to run locally the 6th step, and we'll explore the content of app Python. So here we have we will check if the table exists. So we need to define create order table. We reference the stream here table, and we add the view, pause the view flatten, and here we add also a colon for the timestamp, and then we need to create the order stream here on this table with the SQL.session. Finally, we will merge the result here coming from this is the source, it will the stream, and the target it will be the order table. Think some transformation, and we will update to the merge if matched on this following column, then update if matched there is no action. And finally we down do the resizing of the warehouse to downsize to X small. See the block for local debugging. Here we have the harmonize, we have stream, the order stream, and we have also the order. Here we can see the query history here with the merge that did, and we have the number of rows inserted done. Now we will deploy the procedure to Snowflake, and we need to have remote execution, a call from Snowflake repository. So to do that, we need just to use the Snow CLI as we did for the previous procedure. Create procedure. So it will collect all the required information. It create app.zip and upload to the stage, and finally create the procedure. And now we will execute procedure with a call from Snowflake. It is not local execution. Here we do a call from SnowSite procedure. But there is no new data, so there is no rows inserted or deleted. And now we need to put it from a call. So call the procedure using Snow procedure execute and parameter procedure, and the argument there is an argument successfully done, but there is no to be merged. So now for the seventh step, also we have a stored procedure for the daily city metrics to update the table daily city metrics. So we will apply locally the script, and then we will also deploy the procedure. So here we have this number on the stream in the stream and the 5. If we see the 7th step here, 5. So here we will define a schema in advance here, and all the columns, and we will create a table here from data frame, and we will save it with the session table with the schema and table name. So here the table is saved in Snowflake without data. So, and we will check also if the table exists to not erase it. And here we will merge the content in this table coming from the stream and table, and create a data frame order using session table with reference the table, and select the required column, do a group by here, order timestamp date, and there is the aggregation, and even do a call to in for some transformation, and finally the final aggregate will be merged and to the when matched to update and when not matched to insert, and finally we will resize downsize the warehouse to be x small. So here the local execution is successfully done. So I have this number that is inserted in the daily metrics. So we need just to deploy the procedure. We will use the same syntax. So with the Snow CLI, Snow procedure create, and we will try to also to execute the procedure. So it's created. Now we need to do a call with the Snow procedure and execute -p and the name of the procedure. I think it will be quick because there is no data to merge. As you can see here, the result. So it is so quick because there is no new data inserted or loaded. The next step here is to orchestrate the job. So we need to execute the following script here. Step for orchestrate. Here this script will create tasks. So we have create or replace task using this warehouse, and it will be executed only if the stream has data, and it will do a call to this procedure, and the second task will be unchained after the first one, and it will also check if the required stream has a data to do a call, and then we manually kick off the task and check some metadata. So let's do that from here, and it is done. So perfect. Now finally here we need to do or simulate an incremental load here. We need just to copy in the header table and the detail table some data for only the year 22. The year 22 is a filter, and we will simulate. So let's do that. I will pause the video because it takes a little bit. So here we orchestrated the jobs here from the query history. Here now with Snowflake tasks, Python API and the Snow CLI is general available, and we could transform the SQL code to Snowpark Python code and to create the required tasks. So here we did the process of the incremental data, and here we will check if, because it is in progress. So it is completed. Here I use the same SQL that I used before, just to check before and after the content of the table. And here I see that there is some changes here. For example, here for the row pause, here I have 335, and here I have 13,093. So the incremental load is done, and the task will be executed also just to load the tables according to the rules. Now the last step, we will use Git just to make automatic integration. So we need to have a local change and commit that, and kick off the Git repository. So the procedure and all the required information are in quick start. Here I have the Git repository is mine. So here with the action section for the setting, here secret and variable. So here we need to define these detail for the warehouse, the account, the database. This detail will be used to deploy the code immediately after the kickoff from Snowpark to GitHub. So let's do that. For these variable are already initialized. So the change here will be to substitute this procedure with this one, and we will use a third-party package. So as you can see here, I put in comment this one and I activate this one. I will save that. And you see that here I have change for the Git. And the second change, I need to put the third party package in this requirement. Here it is IP. I need to do that. Save. So I see here in the Git that I have two. I need to validate the stage. One. For this one, I do commit this change purpose. I validate, save, and now we need to sync the changes. The remote repository. Yes, we need to push, and we need to check on the Git action state. I refresh. As you can see here, the change for demo purpose is in progress. If we try to drill down for that, see that the deploy is in progress. Let's see more detail. Here we have the setup, and here we have, as you can see here, is create procedure, create second procedure, and create the function here. So here it is the deployment of all the objects, and this is done because we have here in the Git we have build and deploy. So here we have this build and deploy YAML model that will all this stuff, check out the repository, install the required, and it will use this secret from the variable that we initialized before. And finally, it will use the Python deploy, and the Python deploy here, it is in this section. The Python deploy Spark here, it will loop, it will ignore some folder, and it will loop and identify Spark application with app.toml. And finally, it will generate a string to create procedure or create function and execute with command line snow CLI. So this is how it is done. So we see that the deploy is successful. So here, since we did a small change in the procedure, I think in the function here, we will see that the signature of the function changed. We see that here we are using the third-party package. It is spicy, so the deployment is done immediately when we activate the sync with the Git repository. So it is a nice feature. Finally, I will report in another video the Excel load because I think it is a little bit long. So this is for Git change. This is the step that we saw. Here for the load, I will report it in another video. And here I have some scripts just to see the inventory from the information schema to see the content and the list of objects for each schema in the database. So that's all for today. Thank you very much. It is a little bit long video, but it is a very important video because it take the advantage of many objects and many features from Snowflake. And today, Snowpark is a leader for as API for Snowflake. So thank you very much and have a nice day. Thank you.